had a great lunch. So today, on behalf of SLB Schlumberger, myself, Pradeep Kumar, and along with me, Paula is here to present on impact of high viscosity emulsion on a desalting system with a case study. In India, we have already provided a multiple desalters which is running in all the refineries majorly. So in today's session, we will be having a look to the objective of this particular project that is ongoing right now, and we will have a look into the technical challenges with the existing system and the new systems that is going to be designed, and we have an overview related to the technologies that SLB is having with respect to the AC technology and the AC-DC technology, and the technology solution that we have proposed for this project will be presented, and we'll be having the oil water emulsion uncertainty, how we have evaluated, those details will be shared, and the new desalting system and conclusion will be provided. To begin with, the objective of this particular project was to have a dehydration and desalting system for our customer in US to have the optimized retrofit installation with their existing dehydration system. They are having a plant which is running over 20 years, more than 20 years, which is producing the oil, and they are treating with the help of the desalters. But the present issue is that they are having the design which is done for 28 to 30 API oil, but they have heavier oils which are being coming up to the range of 22, and the design requirement is for 15 API. With the same system, we have to achieve the particular oil specification which remains the same even for the lighter oil and the heavier oil, which is 0.5% BSNW as the outlet of the desalter and less than 50 ppb salt. In comparison with the refinery desalting requirements, it might be very higher, because typically in refinery we will be achieving a less than 0.1 ppb, 0.1% BSNW and 1 ppb salt. So this is for the upstream system where we have this particular higher specification. SLB's strategy in this project was to upgrade the existing technology by evaluating the performance requirement. The existing system which the plant was having was the typical system that is shown as in the image, with the separators and the heat exchangers with the pumping systems. Like, as I already mentioned, the existing system was designed for treating oil of 28 to 30 API, but eventually the system, the plant will start receiving oil which is of 22 API, which is much heavier. Because of this, the outlet specification with respect to the BSNW and the salt were unable to meet. The main reason when we evaluate into this particular challenge of treating the heavy oil was with respect to the design technology that we have in the plant. We typically have an AC technology system which will be having a 3 set of electrode layers, where each layer of electrode will be connected to a power unit, and the power unit will give the signals to the grid layers which is present in the AC technology desalters. When the crude is going to be introduced in a piping riser assembly, which is a mechanical system which is kept inside the desalter vessel, the fluid will get introduced into the electric field. Once it is getting introduced into the electric field, the water particles will be getting affinity towards the electrode particles, and it will tend to have the dipolar attraction, where the acquired positive and the negative charged water droplets will attract together and eventually settle at the bottom of the vessel. Whereas the crude oil, which will be having no affinity towards the electrode plate, will directly tend to move to the top of the vessel, and it will be eventually taken outside. When we go for AC-DC technology, we'll be having a vertical plates which is having a series of plates which is kept from tan to tan distance of the desalter throughout the vessel, where we'll be having the electrophoresis principle which is going to take place, where the water droplet itself will be having highly acquired charge that will be capable to attract the water droplets and have a separation which is almost 6,000 times better than the dipolar attraction. Because of this particular vertical plates electrodes, we'll be able to achieve the desired outlet specification with the separation of water and thus the salinity. This can be achieved with a single power unit with the diode, rectifier diodes, which will be converting the AC-DC signals into this particular desalter system. Over to you, Paul.